be efficient with trigonometry, we need to memorize what is called the unit circle. So today we're going to develop the important angles and ordered pair values that belong in quadrant 1 of the unit circle. I'm going to start off with some pretty basic things that you know, like there's an x-axis, it's horizontal, y-axis is vertical. Every single ordered pair that is graphed is an x comma y. For our purposes on the unit circle, the important ordered pairs in quadrant 1 are right there. We also have some important ordered pairs on the axes. You know from past knowledge, if a unit circle has a radius of 1, then this ordered pair down here on the x-axis would be 1 comma 0. And the ordered pair up on the y-axis would be 0 comma 1. Those are things we already know. Other things we already know that are pretty basic. An angle that lands on the x-axis is a 0-degree angle. A quarter of a circle is a 90-degree angle. 0 degrees is the same thing as 0 radians. A quarter of a circle, now be careful, we could convert 90 degrees converted to radians would be pi over 2. A whole entire circle is 2 pi, so a quarter of an entire circle is pi over 2. A second way to come up with that value. Halfway through the quadrant, half of 90 degrees is 45 degrees. Half of pi over 2 is pi over 4. You could also take 45 degrees times pi over 180. However, this is a no calculator unit, so you'd have to simplify that without a calculator. Every single angle on the unit circle can be turned into a right triangle. Every single right triangle would have the important angle close to the origin, a horizontal leg, which represents an x value in an ordered pair, a vertical leg, which represents a y value in an ordered pair, and a hypotenuse, which matches a radius of 1. So all the important angles. Let's start by making the 45-degree angle into a right triangle. I'm also going to drag out some workspace here. In a right triangle that has a 45-degree angle, we would have to know that the other angle is also 45 degrees, which makes this an isosceles triangle. The legs have the same length because it's on the unit circle radius of 1. To figure out the x value, I could use Pythagorean theorem. A squared plus b squared equals c squared. That gives me 2x squared equals 1. Divide by 2. Take the square root. Square root of 1 is 1 over square root of 2. And we need to rationalize. So the length of my legs is positive or negative root 2 over 2. Of course, the length is always positive a negative might appear depending on the quadrant. In quadrant 1, all of our coordinates are positive. So the x value in the ordered pair for a 45-degree angle is root 2 over 2. And since the y value, since the other leg is also the same, the y value is root 2 over 2. Let's look at that angle. That angle and that angle divide a quadrant into thirds. So 1/3 of 90 degrees is 30 degrees. And 30 degrees plus 30 degrees is 60 degrees. 1/3 of pi over 2 is pi over 6. And pi over 6 plus pi over 6 is 2 pi over 6, which can be reduced to pi over 3. So now, if I want to change my 30-degree angle into a right triangle, what's most helpful, besides remembering that the radius is 1, so the hypotenuse is 1, is that a 30, 60, 90 triangle is half of an equilateral triangle. And in an equilateral triangle, all the side lengths are the same. That means the short side of the right triangle is half of the hypotenuse. If you can get that far, then you can use Pythagorean theorem to find the x value. X squared plus 1/2 squared equals 1 squared. 1/2 squared is 1/4. 1 squared is 1, which is the same as 4 over 4. Subtract 1/4. Take the square root. And in quadrant 1, we want a positive x value because of the positive direction. So my ordered pair right here for 30 degrees is root 3 over 2, while my vertical y value is 1/2. And finally, if you recall that a 60, 30, 90 is very much related to a 30, 60, 90, this ordered pair would be the reverse of the 30, 60, 90. Because as a right triangle, you'd have the short leg along the x-axis and the long leg that's vertical. Get rid of that space and remember the ideas of our trig ratios. Looking at the right triangle, the generic right triangle, radius 1, x along the horizontal, y along the vertical, just like our axes. Sine of any given angle is always opposite over the hypotenuse. Y over 1 is just y. Cosine is the adjacent over the hypotenuse. Cosine is x. That makes every single ordered pair that we just created a representation of the cosine of that given angle and the sine of that given angle. So in memorizing the unit circle, we know all the trig values for all of the special angles. Then we can use those two trig values to get the other 4 trig functions. Tangent is opposite over adjacent, which is the same as doing sine of theta divided by cosine of theta, since sine is y and cosine is x. Cosecant of theta is the reciprocal of sine, secant of theta is the reciprocal of cosine, and cotangent of theta is the reciprocal of tangent, which also could be thought of as cosine over sine. A lot of connections that we're hearing throughout the study of trigonometry. Sooner we memorize quadrant 1, the quicker it will be to translate it to the other 3 quadrants. Only things that would change would be positive and negative values and the size of the angles. We will look at those other 3 quadrants starting tomorrow. The reason for memorizing the unit circle is so that we can quickly evaluate trig functions of different angles. Eventually, we will be using these trig values to graph trig functions. I'm going to drag a unit circle out here to refer to as I explain these. The sine of 30 degrees. So first of all, I identify the 30-degree angle. It's right here. So this is the ordered pair I look at. All ordered pairs on the unit circle represent the cosine of a given angle and the sine of a given angle in that order. So the sine of 30 degrees is 1/2. The cosine of 45 degrees is root 2 over 2. The cosecant of 90 degrees, using this ordered pair at 90 degrees, is the reciprocal of sine. The reciprocal of 1 is 1. The tangent of 60 degrees is sine over cosine, or y over x. So I would take root 3 over 2 divided by 1/2. Instead of dividing fractions, we multiply by the reciprocal. The 2's cancel, making the tangent of 60 degrees root 3. The secant of 45 is the reciprocal of cosine of 45. So the reciprocal right here. The reciprocal of root 2 over 2 is 2 over root 2. We rationalize. And 2 root 2 over 2 simplifies. That makes the secant of 45 degrees root 2. Drag my unit circle so we can do the others. Sine of pi over 4. Root 2 over 2. Cosine of pi over 6. Root 3 over 2. Cosecant of 0 is the reciprocal of sine, and the reciprocal of 0 is undefined. Tangent of pi over 4, after this ordered pair, is sine over cosine, and anything divided by itself is 1. Secant of pi over 2 is the reciprocal of cosine. The reciprocal of 0 is always undefined. If you have the unit circle memorized, it makes evaluating trig functions very easy.